Hey guys, in this video, we'll talk about part 3 of NIST Zero Trust Architecture white paper, logical components of Zero Trust Architecture. Like last video, I'll use ZT and ZTA as abbreviations of Zero Trust and Zero Trust Architecture. In last video, we discussed an abstract model of Zero Trust access. A subject needs to be granted by policy decision point and corresponding policy enforcement point first to assess an enterprise resource. And part 3 of this white paper is mainly talk about this model. Let's dig into this model and its components. So this is a complete version of this Zero Trust access model. Before we introduce these components one by one, there is one thing we need to know is that this is an ideal Zero Trust access model. There are several ways that an enterprise can implement Zero Trust architecture for its workflow. But it's not necessary to use all these components. So these are 3 variations of Zero Trust architecture approaches. We'll introduce them in detail later. Now let's make this clear. We call them variations because neither of them implements the whole Zero Trust access model. One approach only uses like some components should in Zero Trust access model. And these approaches vary in the components used and in the main source of policy rules for an organization. Of course, each approach implements all the tenets of Zero Trust. They follow all the requirements, but one approach may only use 1 or 2 components, or only use 1 or 2 tenants as the main driver of policies. Now let's check control plane here and data plane here. We can see the policy decision point is broken into 2 logical components: the policy engine and policy administrator. And control plane consists of these 2 components. Logically, Zero Trust architecture logical components use a separate control plane to communicate, and application data is communicated on a data plane. Let's zoom in and check this control plane. The control plane is used by various infrastructure components, like both enterprise owned, from service provider. So this control plane is used to maintain and configure access, judge, grant, or deny access to resources, and it can perform any necessary operations to set up communication paths between resources. In short, this part is the access controller of the system. You can get in or not. It's all up to this control plane. The data plane is used for actual communication between software components. In another word, control plane only control access. They do not care about data communication. Data communication is all up to here. If you want to access resource, you need to use control plane first, because you need to get granted to by control plane. For example, control plane could be used by like PA and PP to set up the communication path between subject and enterprise resource. you can use all the resource and service here, as long as a path was established. Let's check some more example. Then we can see it's clear. The most common application we can see now in real life used as a control plane is two-factor authentication apps. So here are some popular two-factor authentication apps. So how do these apps work? For example, if you are logging in your Google account on a new device, after you enter your Google account and the password correctly, Google will require you to open your Google Authenticator on your phone to get an authentication code and enter this code to confirm it's you. And Google Authenticator here is a typical control plane. It doesn't provide any data or resource you want, just to make this process secure. Yeah, that's what it is for. Just grant you access. And this two-factor authentication is practicing zero trust principle already. It doesn't trust you because you have the right account and password, but it verifies again. Of course, two-factor is the most basic one. This process can be set to multi-factor authentication if needed. Now let's check these components on the side. Except for the core components used to implement a zero trust architecture, data source provide input and policy rules used by the policy engine when making access decisions. And these components include like local data source as well as external data source. They provide these data source and policy, and policies policy engine can use as reference. So first component, CDM system. Full name of CDM system is continuous diagnostics and mitigation system. This component gathers information about the enterprise assets currently state and applies updates to configuration and software components. A CDM system is to provide the policy engine with information about the asset making an access request, such as whether it's running the appropriate patched operating system, the integrity of enterprise approved software components, or presence of non-approved components, and whether the assets have any known vulnerability. CDM systems are also responsible for identifying and potentially enforcing a subset of policy on non-enterprise device active on enterprise infrastructure. And the next one is industry compliance system. This components ensures that enterprise remain compliant with any regulatory regime that it may fall under, including all the policy rules that an enterprise develop to ensure compliance. And the next component, threat intelligence. These components provide information from internal or external sources that, as long as they can help policy engine make access decisions. This could be like multiple surveys that take data from internal or multiple external source and provide information about like newly discovered attacks or vulnerabilities. This also used. This also can provide newly discovered flaws in software and newly identified malware, and the report and the reporting attacks on other sets that policy engine will want to deny access to from enterprise assets. Next component, activity log. The full name is Network and System Activity Log. The enterprise system aggregates access log, network traffic, resource access actions, and other events that provide real-time or near real-time feedback on the security posture of enterprise information system. This information needs to be provided by activity log system. And the next one, data access policy. These are the attributes, rules, and policies about access to enterprise resource. This set of rules could be encoded or dynamically generated by the policy engine. These policies are the starting point for authorizing access to a resource, as they provide the basic access privilege for accounts and applications or service in the enterprise. These policies should be based on the defined mission roles and the needs of organizations. The next one is PKI. It's Enterprise Public Key Infrastructure. This system is responsible for generating and logging certificates issued by the enterprise to research subjects, surveys, and applications. This also includes the global certificate authority ecosystem and a federal PKI, which may or may not be integrated with enterprise PKI. The next component is ID management system. This one is very important. It's responsible for creating, storing, and managing enterprise user accounts and identity records. This system contains necessary subject information like name, email address, and other enterprise characteristics such as roles, access attributes, and assigned assets. This managed system often utilize other systems for artifacts associated with user accounts. This system may be part of a larger a community and may include non-enterprise employee or links to non-enterprise assets for collaboration. And the last component is security information and event management system. This system collects security-centric information for later analysis. This data is then used to refine policy and warn of possible attacks. So these are the main components for Zero Trust access model. Now let's check these three approaches that can be used to build Zero Trust architecture. Use these logical components we just mentioned. The first one is enhanced identity governance driven Zero Trust architecture. So this approach to developing a Zero Trust architecture use the identity of actors as a key component of policy creation. For this approach, enterprise resource access policy are based on identities and assigned attributes. The primary requirement for resource access is based on the access privilege granted to the given subject. And in layman's terms, this approach is like role-based access control. This approach works well for enterprises that use cloud-based application service because they don't have their own security components, like enterprise using SaaS. And the next approach is logical migration segmentation zero trust architecture. We talked about this one in last video. This one is to implement a zero trust architecture based on placing individual or groups of resources on a unique network segment protected by a gateway security component. It's like, don't put all your egg in one basket. The last approach uses network-based segmentation. It uses the network infrastructure to implement zero trust architecture. This approach basically is using user network location and network properties to grant access. So it's also called software-defined parameter approach. To be honest, I feel this one is like a conventional parameter-based security model. But this zero trust white paper lists it here, so let's just be aware of it. So these are logical components in zero trust architecture and the three zero trust architecture approaches. So now let's summarize the main feature of these components. First, it's not necessary to use all the components to implement a zero trust architecture. We said one approach may only use one or two components. And secondly, logical components do not necessarily need to be unique systems. A single asset may perform the duty of multiple logical components because they are logical components, not physical. And these logical functions could be combined into one asset. At the same time, all logical components may consist of multiple hardware or software elements to perform the tasks. One component does not mean one hardware or one software. So that's all the content for logical components of zero trust architecture. Thanks for watching. See you in the next one.